Good morning. Hi, everybody, and welcome. Welcome today. We're going to today's CNCF webinar is about continuous integration and delivery with Kubernetes. I know it's something that I'm deeply passionate about, and I'm really excited for this session and our guest speaker. My name is Lachlan Evenson. I'm a principal program manager at Microsoft and a CNCF ambassador, and I'm happy to be here today hosting this wonderful content. I'd like to thank you all for joining and being here today. It's great to have such fantastic numbers. I know it's an interesting topic in the open source ecosystem. And I would love to welcome and extend a warm welcome to our guest today, our guest speaker. His name is James Strachan. He is a senior architect at CloudBees, and he will be presenting his expertise on CI, continuous integration and continuous delivery on Kubernetes. Just a little background about James. James is responsible. He's been in the open source community as a developer for many years, creating many great projects, including Groovy, Apache Camel, Dom4j, and Jackson. He's been working most recently with Jenkins on Kubernetes and was previously working at Fabricate at Red Hat. So today he's going to be sharing CI and CD with Kubernetes. And without further ado, I'd love to hand it over to James for this exciting content. Thank you, James. You take it away.
Thank you.
Before I forget, I have two housekeeping things. I got a little overexcited, so sorry to cut you short. So during the webinar, you're all on mute. All the attendees are on mute. There is a chat window down the bottom, but we would ask that all your questions be held to the end. And as you want to ask them, there is a QA button down on the bottom panel. You go ahead and click that Q&A button, and you can drop your questions in there. There will be time allocated at the end for answering each of those questions as we get through to it. So this session will be about 40 to 45 minutes, then questions at the end, and I will be facilitating the questions in the Q&A section. So we ask that you ask them there. And also this session is being recorded, and there will be a link set out after the presentation. So sorry about that, James. I will now hand it over.
No worries.
Thank you.
Thank you very much. Thank you. So hello, everyone. Let's get started. So before I talk about Jenkins X, I just want to briefly talk about the software ecosystem right now. So a lot has happened in the last 5 years that's really changed what it even means to deploy, develop, deploy, test, and orchestrate software. So Kubernetes is an amazing thing. I love it. I'm hugely passionate about Kubernetes. It's one of the most amazing open source projects I've ever used in my life. It's amazing stuff. So Kubernetes in 2018, Kubernetes is basically won the container orchestration game. In 2018, I think today EKS on Amazon is announced. AKS is meant to be GA like this week or next week. GKE has been around for a while. So all the big three cloud providers, Amazon, Google, and Microsoft, all have managed Kubernetes as a service. Kubernetes is amazing technology, but friends don't let friends install Kubernetes, right? It's kind of tricky to install and manage. So what you really want to do is outsource that to someone else. If you're using the cloud, use a public cloud provider to manage your Kubernetes. Managed Kubernetes services are amazing. You just click a few buttons in the web console, and you get a fully managed Kubernetes cluster that if a node dies, it recreates one. You can expand and collapse your node. You can do auto-scaling in it. And the cloud provider manages and installs Kubernetes for you, which is truly amazing. 2018 is the year that pretty much everyone in the middleware business and software business has adopted Kubernetes. So Docker has adopted Kubernetes, Oracle and IBM, Cloud Foundry and Pivotal support Kubernetes in PKS. All the public cloud providers pretty much have a managed Kubernetes service now. And then for on-premise, there's lots and lots of vendors out there like Heptio and Red Hat and various others that support on-premise managed Kubernetes. So Kubernetes has kind of won the container orchestration game. So now a lot of developers are now faced with the challenge of learning Kubernetes and learning how to use it, and then how to do things like CI and CD. Coupled with this, we're all increasingly moving towards microservices, and so we want to, everyone wants to be a high-performing team, so we all want to go fast and do small little iterations of code and get that code quickly into production as quickly as possible, so you can get feedback from real users to know what's good and what's bad and how to improve. So we're all trying to iterate and continuously improve. So we all basically want CI and CD on Kubernetes. This is where we're all kind of aiming for, or aiming towards. We want automated CI and CD so we can just spin up our code and stuff just happens. Today, if you're trying to be a high-performing team, you're now faced with all this stuff to figure out. So you need to set up a cloud somewhere, or pick a cloud. You need to set up Kubernetes clusters. You need to set up environments like development, testing, staging, production. You need to move your application code into containers, so you start building Docker images now rather than tarballs or jars or whatever. You need to figure out how to deploy your application on Kubernetes, whether you generate some YAML or whether you use Helm charts. Then you need to figure out how to do the actual continuous delivery thing of releasing Docker images and YAML, and then how to do promotion. Like, how are you going to promote your versions of your application from testing to staging to production using best of breed DevOps practices like immutable infrastructure. There's also a new term in your DevOps handbook called GitOps now, which came from the Weave folks, and it's basically a technique of doing operations through using Git. In other words, store all of your operational configurations, like what applications are running in staging and production and what their configurations are and so forth. Put that in Git and use Git as the master record for all of your environmental configurations of your clusters. Why use Git? Well, Git works really, really well for source code. So let's operate software through source code. So that, for example, rather than changing something using kubectl apply in production, and then nobody else on the team knows what you just did, and all of a sudden production breaks and nobody really knows, put all of that stuff in a Git repository and then use GitOps. So then you can see via pull requests and commits who changed what when in production. And then you can do, importantly, you can roll things back when things go bad in production, right? So GitOps is a really nice approach. Then we need to automate everything and get feedback. So there's all this stuff that we all have to do as developers, which is kind of unnecessary heavy lifting, right? We all just want to get all that stuff done and then do what we really meant to be doing, is focusing on delivering actual business value to our customers, which is kind of what we should be doing. So we have this kind of problem. How do we deal with all this stuff? And this is where Jenkins X comes in. Jenkins X is your personal butler, your seafaring naval butler, who sails the seas of continuous delivery to help chart your course to whatever. Yeah. So Jenkins X is going to try and help you deliver continuous integration and continuous delivery on Kubernetes. So Jenkins X is a new sub-project, a proposed sub-project of the Jenkins Foundation. It's all completely open source. And Jenkins X is really aimed at focusing crystal clearly on automating CI and CD for Kubernetes. So how does Jenkins X help? First thing Jenkins X does is it combines a whole bunch of best-of-breed open source tools from the Kubernetes ecosystem together into a single, simple to install and configure system. So Jenkins X installs and configures a whole range of open source projects. One of the lovely things about the CNCF and Kubernetes is there's a huge range of really awesome open source projects that we all should adopt. One of the challenges with the Kubernetes ecosystem is keeping track of what's all the good stuff and what should you be using to implement your CI and CD. So the whole ecosystem of open source around Kubernetes is amazing and fantastic and cool. And there's lots and lots of pieces of open source software that does lots of different things well. So for example, Jenkins X comes with lots of different things, but just to name a few, we use Helm as a package manager for packaging up your YAML templates so that you can install them into your staging and your production environments. And Helm does a few things, but it's a package manager like Helm, like a Yum and NPM and those kind of things. But it also does kind of configuration management. So it helps you, when you install a Helm package, which we call them charts, Helm takes care of managing any environmental configuration you need to override as you install it. Then you can just upgrade that application as a new version comes out, and it keeps your configuration with the new version. So you can roll forwards and backwards while also dealing with configuration management. We use a tool called Scaffold from Google, which takes care of abstracting away the differences between how you're actually going to do the Docker builds on the Kubernetes cluster. I won't get into it too much right now, but there's all kinds of different ways of building Docker images on a Kubernetes cluster, using the Docker daemon directly, using an open source project from Google called Canico that avoids talking to the Docker daemon to build Docker images, or things like Google Container Builder or various other cloud services. So Scaffold takes care of that, abstracting away of building Docker images and doing various development things, which I'll show you later. There are various other tools like Nexus for handling artifacts. You might be using Kubernetes, but you still want to be releasing things like, if you're doing, say, Spring or Java, you want to release POMs and jars and libraries and stuff. You might be using Node and doing NPM stuff, and you might be releasing various other artifacts. There's an open source project called Monocular, which is kind of like an open source app store for browsing all of the applications your team has built and Jenkins X has built. So it's kind of like an app store where you can look at all the different apps and all the different versions to help teams share their apps with other teams. So you can kind of search and find applications that you're building. So Jenkins X automates the installation and configuration of all that stuff. So that's kind of cool. But the other thing it does, which is super important, is it automates the CI and CD for your actual application. So the actual apps you're developing and building, it automates the creation of Docker images, the creation of Helm charts, which are the things that installs things in Kubernetes, and it sets up the CI and CD pipelines, which we'll show you in a few moments. Jenkins X also automates the use of GitOps to do promotions between environments. I'll show you how that all works in a few moments, but the basic idea is we use Git repositories for all the environments to manage promotion and configuration management of the environments using a single Git workflow, using pull requests and so forth, so that your team or possibly multiple teams can work together to approve promotions and so forth. And finally, Jenkins X gives you lots and lots of feedback. So that all sounds kind of cool. How do we use Kubernetes and Jenkins together? So we basically need a Kubernetes cluster and Jenkins X to be installed on the cluster. Now, not everyone has a cluster already. So there's a couple of different approaches. But before we get that far, the first thing you need is a binary called JX. So if you already use Kubernetes, you know about kubectl or kubectl, depending on how you say it, kubectl. There's a kubectl binary that you use to interrogate Kubernetes. Jenkins X has its own binary called JX for Jenkins X, which is a Go binary. It's statically linked binary that you can download for Windows, Mac, and Linux. If you use a Mac, you can use Brew to install it. If you use Linux, you can use curl, or you can just go to that web page and download the binary and just put it on your path. So install JX, because you will use that command line quite a lot if you adopt Jenkins X. And we hope you do adopt Jenkins X, by the way. Then these are the two commands to install Jenkins X and set it all up. So there's two options here. The first option is to create a new Kubernetes cluster and install Jenkins X on top of it. The second option is if you already have a cluster that you want to use, you just type JX install. We kind of prefer the first option because then you can just spin up a new cluster, play around with it, and then if you want, just kind of tear it down. And it's kind of an isolated cluster that you can just kind of play with. We also prefer you to use the public cloud to start with. Either Amazon or Google or Azure, they're all supported. You just type that one command in, JX create cluster, then AWS for Amazon, GKE for Google, AKS for Azure. We have a bunch of other providers, and we're trying to provide as many clouds as we can, and we're trying to, EKS was just announced pretty much, so we're hoping to add EKS to the list very soon. So we rather you use the public cloud because then webhooks work with GitHub and all that kind of stuff. But if you have a cluster already, use that. That's all fine. JX install works as well. There's a URL there that you can click on to get more details of how to do it all. And what I'll show you is a very quick demo of how the install works. This demo is sped up a little bit. We type JX create cluster GKE. It asks you a few questions about machine names and zones and whatnot and machine types. Then it spins up a Kubernetes cluster. It sets up the ingress so you can talk into the cluster. Then it installs the Helm chart for Kubernetes, for Jenkins X. And then the final thing it does is set up two Git repositories for the GitOps piece, which you'll see in a moment. So the whole thing, this is sped up a little bit. The whole thing on my laptop on GKE tends to take 2 to 3 minutes from scratch. On the other clouds, it's a little slower, but within say 10, 15 minutes, you should be all set up and ready to go. So once you've typed your JX create cluster command, you should be all set to now enjoy and have fun with Jenkins X. So what does Jenkins X give you? So typing that one command in, what do you get? So the idea is once you've run that one command, each team gets their own development tools environment. So basically Kubernetes namespace where all your development tools run and all your builds run and so forth. So right now each team gets their own master, so their own Jenkins master. So you might use Jenkins already in your job, and you might have like a big Jenkins server with a gazillion jobs in it. We give each team their own Jenkins master. So if you decide to use the Jenkins UI, you only see your pipelines and not everything in your entire organization. Each team also gets an elastic pool of build agents for running your builds. So you don't have to fight over this kind of limited build queue. In Jenkins, each team gets their own elastic pool that if Kubernetes has enough capacity, all your builds just run immediately. Also, there's things like Nexus and Monocular. In addition, each team gets their own staging and production environment. So in other words, each team can then create apps and go straight to the staging environment automatically without having to have a meeting with other teams and agree that you're allowed to do this, right? Each team can just deploy their stuff immediately to the staging environment. Out of the box, we do automatic promotion to staging, and then we leave promotion to production as a manual step. You can create as many environments as you wish and call them whenever you want, and an environment can either be automatic or manual. The out-of-the-box defaults are staging and production, and staging is automatic and production is manual. But you can, we hope everyone becomes automatic for everything, right, eventually. But we've left it as this kind of safe default, and then when you're happy and confident, you can automatically promote to production. So let me switch gears now, and let me just do a live demo of Jenkins X. And I'm going to do a live demo of Jenkins X on Google Cloud. And I'm going to use GitHub and Google Cloud. So what could possibly go wrong, right? A live demo on a webinar over hotel Wi-Fi. This could be epic. So I've got the JX binary on my path. And if I type JX, it gives you all the gazillions of commands that are inside the JX binary. Let me clear that because it's kind of noisy. So the first command I'll show you is JX getIn for get environment, lists my environments that I've got. So I've got a development environment, I've got a personal edit environment, which I'll show you later, and then a staging and a production. So what I'm going to do now is I'm going to create a brand new app. If I type JX get app, I don't think I have any apps running. So I've got no apps running. So I've got a completely empty Jenkins X environment. I'm going to create a new application. We support a whole bunch of different wizards and languages for creating brand new projects. You can also import an existing project with JX import. I'm going to start off creating a brand new microservice. And since this is CNCF and so much in the Kubernetes ecosystem uses Golang, I'm going to do a Golang demo in this example. We support Python, Perl, PHP, Java, obviously Spring Boot and various other things, but I'll stick to Golang for this demo. So I'm going to do the create quick start command, which has a library of different quick starts to use as your initial base of a project. And there's a whole raft of these. And you can add your own quick starts into this menu and configure the quick starts on a per team basis so that you could just pick the approved languages or frameworks or whatever in your organization. So I'm going to pick the Golang example. Oh, actually, I need to go into the, I'm in completely the wrong directory. No, it's okay. I'll stay here. Let me create a Golang example, and I'm going to call this CNCF Rocks. There we go. Actually, that's a dodgy name, but never mind. It looks like CNC Frocks, but never mind. So we've got a new example. I'm going to say use my GitHub username. Yes, that's good. Would I like to initialize a Git repository? Yes. So it's copied these files onto my file system. So it's a very simple app, as you can probably see. It's a main.go and a couple of shell scripts. So that's the quick start. It's created from a library of quick starts. Now it's going to run something called a build pack, which is going to add a bunch of extra files, which I'll talk about in a moment, to be able to do CI/CD. Now it's going to push this Git repository onto GitHub so that we can use it from different people can work together as a team. So I'm going to use my personal GitHub user, and I'm going to use that name as a Git repository. So now Jenkins X is going to do a Git push, or I'm going to create a project on GitHub and do a Git push, and that will work. So now we've got a new Git repository on github.com. So let me just show you that I'm not cheating. Actually, I'm just going to copy and paste this command here. This command is kind of handy. This is going to output to my terminal any activity in terms of pipelines and builds that take place on my project. And I'll just kind of keep that running in the background. So we're basically watching a custom resource in Kubernetes that describes all the pipelines happening on my project. So just to show you that I'm not cheating, I'm going to click on this GitHub URL to show you the project. So this is github.com, recently acquired by Microsoft, which I think is awesome news. I couldn't think of a better place for GitHub to end up. I think Microsoft is an awesome place for GitHub to be, and I'm super excited to see what happens with VS Code inside GitHub. That could be epic. Anyway, so this is github.com. This is a project I just created. You can see it's under a minute ago. There's the Go source file that I'll probably edit fairly soon. Notice there's a bunch of extra files being created. There's a Docker file, which because the quick start didn't have a Docker file, it's added a Docker file. The build packs added a Docker file so we can make a Docker image for this code. It's added a Jenkins file, which defines the CI and CD pipelines. And it's added a scaffold YAML so we can use scaffold to do interactive development. I think it's added some Helm charts. Now notice all of this, we don't even need to look at these. In fact, I'm not even going to show you them. We don't need to look, it doesn't matter. But if you really, really care and you really want to tweak, say, the Docker file, you can just edit the Docker file in Git, do a pull request, merge to master, and you've now got a new Docker file. Ditto the pipeline or the chart or whatever. But the idea we're trying to do is a lot of teams are adopting Kubernetes, and a lot of developers don't know what Kubernetes is. They don't know what Helm is. They don't know how to write Docker files. So we're trying to automate all of this stuff so that developers don't need to know or care. So you could squint and see this as a kind of a serverless way of working with Kubernetes, because you don't have to know Kubernetes is there. You don't have to know about all this stuff. But we're not, unlike serverless, we're not hiding Docker file, Jenkins files, and charts. You can go in there and tweak these things to your heart content if you wish. Now, you might have noticed a bunch of activity that's happened. We've already released 001. So what happened there is I typed one command. We spun up a brand new quick start in Git, and it's already created a release, a versioned release, 001. We create semantic versions. So we start at 001, then we go 002, and we go up incrementally. So we've created a new release number, 001, and we've tagged the Git repository with the source code, and we've generated some nice release notes. We've also, under the covers, created a Docker image, tagged that with 001, and pushed that to the Docker registry. We've also created a Helm chart for 001 and pushed that into the Helm registry, into Monocular. So anybody can now deploy that application right now in any Kubernetes cluster just using Helm directly without using any of the Jenkins X GitOps stuff if you chose to do so. I don't think you should do that. I think you should stick with Jenkins X, but if you wanted to do that, that's all kind of cool. So we've automatically created a new release. And notice we've created a pull request. Now, what we're trying to encourage is good behavior. We're trying to encourage everyone to become a high-performing team. So as soon as you create or import a project, we want to go straight to the staging environment and release it and go to staging. So that as you then start to develop this thing and do code changes, you do that through pull requests. And we're trying to encourage everyone to release frequently into the staging environment, right? And then you choose when you want to go to production. Notice we've got a pull request. I'm going to click the pull request. This pull request might have merged already. I was too slow. So what we did was generate a pull request and this pull request is on the staging environment. So this is a pull request to change the staging environment via a Git commit. So we've proposed through a pull request a code change to the Helm chart for the staging environment. So if I look at this diff very briefly. Now, you don't need to know about this diff or even care about this diff, but this is the actual code change that Jenkins X automated to do the promotion. So we've edited the standard Helm requirements.yaml file to add a new chart to the staging environment for 001 of this new application, right? So because we've never deployed this application before, it's 3 lines of code that changes. Once 001 is released, and the next time we do the next release, there's going to be 1 line of code changes, which is just the version number, right? And this is just standard Helm stuff in this Git repository, so we can use the same Git repository to do configure Helm charts using the values.yaml stuff in Helm to override the environment configuration of all of these charts. So if you want to configure staging and production slightly differently, you can do all of that in the staging and the production Git repositories, and managing it all with CI and CD in the same way we do apps, right? So that's kind of cool. So you'll also notice the pull request has succeeded. So let me just recap what we did. We did 1 command to create a new project that created a brand new Git repository. That also set up a Jenkins CI and CD pipeline, which then, because we pushed to master, released 001. If ever we want to go to 002, it will automate that. If ever you want to jump, by the way, to say 20 or 300, just create a Git tag and the automatic pipeline will read the Git tags and always take the next highest version number. If you use, say, Maven or you use Node, you can use the pom.xml or the package.json to do major, minor version upgrades as well, or just use Git tags. So we, 1 command line, created a new project and we released it. We've also used the GitOps and the pull request to promote this into the staging environment. And if I click on this URL here, we can see the application running in the staging environment. And there you go. We're now running the application in the staging environment after that promotion. So that's kind of cool, right? So with 1 command line, we've automated the CI and CD of an application and released the version. So now let me show you, let me change gears a little bit. Let me show you how to make a pull request to do a code change. So let's switch to a different terminal, and I call this CNCF Flux, okay. And I'm gonna make a code change. So let me pop up my trusty VS Code. And I'm gonna make a little code change. And you'll notice the Go code is super awesome. It's a super awesome Go code. So I'm gonna add, change the title. I'm gonna add some awesome. So I've changed the source code. what I'm actually going to do is I'm going to create a new issue in GitHub. So I can do that via the website, obviously. I can also create an issue from JX. So I'll create a new issue saying add more awesome. So I've created a new issue there, and there's the URL on GitHub. And now I'm going to do a git commit. I'll use the command line just to show you there's no weird magic. This is just my entire demo now. It can be just vanilla git from the command line. So I'm going to do create a branch. I'll call it fixes, git checkout fixes. And then I'm going to do a git commit, -a, -m, and I'll say fix more awesome. And this fixes issue number 1. And I'm going to do a git push. And that's pushed up to the GitHub. So that's just vanilla Git, like no magic, no weird Jenkins X stuff, just vanilla Git stuff. Now, if I go back to the project, here we go. If I go back to the project website, GitHub is hopefully now going to say, hey, you've just pushed a new branch. Do you want to do a pull request? So we say, yes, let's do a pull request. So I'm going to click the GitHub website and say, let's create a pull request. I'm going to say, create a pull request. So notice now that any second now, hopefully, the web browser should refresh. Hopefully. If I open this terminal, by the way, you should see, notice a pull request pipeline is now chugging along. So because we've created a pull request, the CI and CD that we automatically set up because we're using Jenkins X is now running a CI pipeline on every pull request. So we do releases when you merge to the master branch, and when you submit pull requests, we do a CI pipeline. And the CI pipeline is doing the things that people normally do with CI, right? Check that the pull request, does it compile? Does it pass all the code quality checks? Does everything look good and acceptable? So it's running all those kind of builds. We also, by default in Jenkins X, do something else as well. We do something called preview environments. So whenever you create a pull request, by default, you can opt out of this, but by default, whenever you create a pull request, we do the normal build checks and tests and check everything works. Then we build a preview Docker image for that pull request and push that to a Docker registry. Then we create a preview environment, which is basically a separate Kubernetes namespace for that pull request. Then we deploy the Helm chart into that namespace. So we basically deploy the pull request in Kubernetes as it would be deployed if it was in staging or production before we merge. Now we do this for a few different reasons. The first thing is we're now checking that does the code actually still work in Kubernetes? Like it's quite easy if you're, particularly if you fiddle with environment variables or Docker files or Kubernetes YAML or something, it's very easy to break an application in Kubernetes, right? So the first thing the preview does is check, does this stuff still work in Kubernetes? But the other thing is it really helps us do testing of various kinds. If you're building a web console, for example, sometimes by just looking at the diff on the pull request, you're not quite sure what the change means or how the change is going to look as a UI. In this case, notice that the pull request pipeline has completed so that everything's green, so we can merge this, we're ready to merge. But notice this comment. Jenkins X has already automatically commented on the pull request to say there is a preview environment created for this pull request, and there's a URL that links to the app in the preview environment. So if I click on that URL, that's opening a new environment, a preview environment for the pull request, which has more awesome. So our code change is now running in its own separate environment, isolated from everything else, before we've merged anything. Now, this is awesome on many levels. Like we use preview environments all the time ourselves to build Jenkins X. Particularly with UIs, this is amazing because any code change in a UI, it means you can just look at the UI and test it and have a look at it and see what it feels. You can also do automatic testing, like using Selenium or some kind of load testing or contract-based testing tool. Because a preview environment is literally just a Helm chart, you can make a preview, you can define what that preview environment is completely up to you. So you can deploy other microservices, you can link preview environments to other preview environments, you can add testing applications and various other jobs and so forth. So preview environments are super, super useful, and particularly for UIs. Another thing about preview environments, by the way, is sometimes you need to make a change on multiple microservices. So you might want to make a pull request on a backend service to add a new API. Then you might want to change a front end to use that new API. So you've got two pull requests. You can link together the preview environments of different pull requests so that the pull request on the UI can be using the pull request, the preview environment for a different backend, right? So you can do very sophisticated testing of changes before you've actually merged anything. So this is awesome for hypothesis-driven development, where you just want to experiment, try something out across multiple namespaces and repositories and whatnot, test it all out, and then when you're all happy, let's go crack on, rather than merging everything to master all the time and then having to back out things and dealing with merge conflicts and stuff. So that's preview environments. Now this is working great, so let's hit merge. So we validated did a pull request. It automatically validated it could build. It automatically validated it could run in Kubernetes. We get to try it and look at it. We're happy with it, so we click merge. So now we click merge. Notice that the pipeline is now running a new master build. So now we're going to release 002 of this application. So let me briefly recap what we just saw. That was kind of a lot of looking at consoles and web applications. We wrote one command line, JX create quick start, and that created a brand new project. It created a brand new Git repository on GitHub. It set up the CI/CD pipeline for you automatically. You don't have to look at a Jenkins file or a Docker file or a Helm chart. And then we've automated preview environments on every pull request. And then whenever we merge anything to master, we automatically do continuous delivery into the staging environment. And at any point in time, we can then manually promote that to production using the JX promote command line. So automated CI and CD on Kubernetes. I'm going to leave that release going because it will take maybe a minute or so to complete. And we'll come back and look at it when it's completed. What I'd like to do, because I want to leave plenty of time for questions, so hopefully there's quite a few. I'd like to show you one other thing. So one other challenge that developers face when they start moving to Kubernetes is, how do you develop on it? Like, I've demonstrated CI and CD. So I've demonstrated importing or creating projects and automating the CI and CD and the GitOps piece. But developers want to try, usually you want to try code changes out before you submit a pull request. Now, some people do like work in progress pull requests and use a pull request as like a place to hack on code before they're ready to promote them. But often developers want to hack code locally and just try it out, right? Now, as developers, we're notorious for running stuff on our laptops, which are completely different to the production environment, right? We might have a Mac or a Windows machine, and we might run stuff on a Windows machine, and it seems to work okay, but then it works completely differently in Kubernetes. So we want to encourage people to use the Kubernetes all the time for development, right? Always use the same operating system, containers, and tools all the time, because from a state of DevOps kind of high-performing team thing, we're reducing waste by not testing apps on the wrong thing. We're always testing on the right thing, right? So we're not worrying if things go weird on a Windows box because production doesn't use Windows or whatever, right? So we have a thing called dev pods, which if I switch into VS Code, oh, by the way, let me hide Maven because this project is not Maven. We also have a VS Code extension for Jenkins X, which I'll just show you very briefly. So that what this does, under the covers, Jenkins X is using Kubernetes resources, custom Kubernetes resources to define pipelines and environments and all those kind of things. And so we have a little plugin for VS Code that can watch and browse all of your pipelines. And for each pipeline, you can see what it's doing. And if you can say, right click and say, give me the build log, because I don't know, I want to watch it. I want to look at the gory detail of everything that's happening in the pipeline. Or if a build, usually if a build goes wrong, you want to look at the build logs and stuff. So with a couple of clicks, you can watch what's happening in CI and CD and watch things happening live. So that's kind of cool. And we should notice the pipeline's almost finished. So it should go totally green fairly soon. To implement the pipelines, we use something called a build pod, which is really just a Kubernetes pod with build tools inside it. So if you're, in this case, we're using Go, so there's the Go tools in there, but there's also tools like Git and kubectl and Helm and JX and various other tools, Scaffold. So we have a whole range of tools we use to implement the CI and CD pipelines. We have a thing called a dev pod, which is basically, reuses the exact same pod for pipelines, but for developers to use. So in other words, the exact same version of kubectl and Helm and Scaffold and Docker and all those command line tools we use to do CI and CD, all those tools are available to a developer. So if I open the toolbar menu in VS Code, I can type this open dev pod terminal command. Now what this is going to do is open a new terminal that is actually going to run in Kubernetes. We'll just give it a few minutes to start up. I think my cluster, Usually these things start up really, really quick. Oh, I'm using the wrong demo. That's why it's taking a while. I did this demo about an hour ago, and I was using a completely different dev pod. So this is why it's taken a while to spin up. So this might take a few seconds for this dev pod to spin up. So what happens with the dev pod is a dev pod is creating a brand new pod on Kubernetes. And the dev pod starts up, and then this shell opens in that dev pod. So you're basically using a command line shell, and it looks and feels like you're on your laptop, but really you're running everything inside Kubernetes in the cluster, and it all works beautifully. What we also do is we synchronize the source code from your desktop IDE into the dev pod, so that we can run tests or builds inside Kubernetes using the Kubernetes cluster to do builds. I don't know about you, but if ever I do a Docker build on my laptop, it takes hours. Like my Wi-Fi is kind of slow. It takes forever to download Docker images. Pulling and pushing Docker images on your laptop is really super slow. Building Docker images in the public cloud inside Kubernetes is super, super fast. So as a place to develop, the cloud is amazing. And so the dev pod helps us automate synchronizing code into the dev pod. And then we can like do builds and so forth inside it. Well, this is taking a little while. I might actually switch projects to another a node-based application. I was just doing a demo earlier on Node, so let me switch. That dev pod's taking a while. I think under the covers, Google is now auto-scaling my Kubernetes cluster, and it takes a minute or two for a new node to start up. So while that's happening, let me do a demo over here. This is a Node application. It's basically a similar application, but it's using Node.js. So same kind of thing, Node.js thing. I've got my pipeline here that I can watch what's happening. Oh, and the build's finished, by the way. Just before I show the dev pods, really, really quickly, because I want to leave time for questions, let me just go back and show you one more thing. So we've just released 002 using the pull request. So here's the pull request for 002. The pull request, there we go. There's a pull request that released 002. So let me just show you the diff. So the diff to promote from 001 to 002 is literally just changing one string for the version number, right? So that's nice and simple. You can just look at that pull request and go, I get it. I'm changing this one version. It's nice and simple. The other thing I want to quickly show you was, if I look at the issues, if I look at the release, if I look at the release, notice we've now got two releases, 002 and 001. Oh, maybe it didn't work. I didn't link to the issue. Don't worry about that. Let me move on. But yes, we've got version 002. Right, switching back to the dev pod. Let's see if dev pods are working for Node.js. Hopefully that works. That's looking better. Yes, phew. Okay, our Node.js dev pod is up and running. So I can type ls-al. So I'm now running commands inside a Docker container inside Kubernetes, right? So everything I do inside this command shell is using the exact same software that the CI/CD pipelines are using, and it's using the same Kubernetes cluster and containers and stuff that you're going to use in production. I'm going to type a command called watch, which, if you notice, that built a Docker image, that was pretty quite quick, right? That built a Docker image based on the local source code that's in the file system. And under the covers, this is using scaffold to watch your source code, build a Docker image, deploy it using Helm into a personal namespace, and then it's watching the code for changes. If I go into another terminal and type jx get app, this will wrap horribly because I've got a really big font, but there's the URL of the preview application, so I can open that in the browser. So this is this should start up soon, hopefully. What I can do is I can run a curl loop of this application, and hopefully this pod comes up soon. The demo gods might be allowed to strike. Things are going so well. Hopefully this comes up. What I was going to show you was, so let me just show you the demo first and see if ever this pod comes up. Oh, it's up, it's up. Yeah, phew. Always trust Google Cloud. It always seems to work eventually. It's just sometimes you have to wait a moment. So what I'm going to do is I'm going to make a code chain. So I'm in a desktop IDE, but the source code is on my laptop. So I'm going to edit the source code, and I'm going to add some awesome. So I've edited the source code for this Node.js app. Notice that the dev pod has rebuilt the Docker image, and it's going to redeploy the Helm chart pretty quickly. Usually this is much, much quicker. It's going a little bit slow today. Usually that normally takes like a second or two. It's going a little slow right now. And notice that this curl loop that I've got that's curling the endpoint It's now undeployed the old pod and it's running the new pod, and there we go, awesome. So I basically just changed the source code. Let me do that one more time to see if it's any faster. Very awesome. So I've changed the source code. What's happening under the covers is that source code's been synchronized interactively into the dev pod. The dev pod's going to rebuild that Docker image, redeploy it, and very soon I should see the new pod coming up. So it takes between 2 and like 10 seconds to get a live check. Now, right now, we're doing this with brute force. We're literally making a brand new Docker image each time and redeploying that image from scratch in Kubernetes. We should be able to speed up this UX much faster to do things like, for example, Node can watch for new Node files. We could copy the binary into the pod itself and restart the container or something. So we could do various things to speed this up a little bit, but already we can do pretty quick, rapid deployments of changing some source code and getting a live update of this in Kubernetes and in personal namespace to get really fast feedback to test applications. Now, one thing we're really passionate about, we want everyone to become a high-performing team. So we want to help everyone automate their CI and CD, but we also want developers to be able to go quickly. And we want to try and get developers to use Kubernetes all the time because developing on the cloud is faster than using your laptop. So DevPods is our effort to try get folks developing on Kubernetes. Use your desktop IDE that you know and love, like VS Code, IntelliJ, Eclipse, whatever. Possibly we'll start to use more and more web-based IDEs. So the IDE would then be inside the dev pod, which would be kind of even cooler. Then there's no synchronization. But doing this lets us develop inside the cluster super quickly before we're ready to commit. Then we can just do a git commit when we're happy, and that will then do a pull request, and then we can do CI and CD. So really quickly, that was a very quick walkthrough of Jenkins X. Let me just pop a few links up while we chat. So there's a few links. So basically, Jenkins X is about automating CI and CD on Kubernetes. We want to help make developers super productive and become high-performing teams, and automating as much of the development and CI and CD experience as we can using all of the amazing open source technologies in the CNCF and the Kubernetes ecosystem. If you're at all interested, please go to jenkins-x.io and check it out. There's lots of docs and demos and whatnot up there. Even after this webinar is complete, if you've got any questions at all or any feedback you want to give us, if you go to the community link, where we have a bunch of rooms in the Kubernetes Slack service. So please pop by Slack and ask us anything you like at any point in time, and we'll be more than happy to help you on any questions. And on that, I wonder, are there any questions?
Fantastic. Thank you, James. We do have a bunch of questions, so I just wanted to remind everybody that if you have questions, I see some of them in the chat. Please go over to the Q&A button and re-ask them in there. I've tried my best to capture questions that are in the chat that are not in the Q&A. And now we're going to go through, and I will facilitate asking these questions to James, and we'll see how many we get through in the time we have remaining. So Andrew Whippler asks, does JX support private cloud / bare metal Kubernetes clusters?
Yes, so great question. I should have made that a bit more clear. Jenkins X is designed to work on any Kubernetes cluster, so anything at all, wherever it is, whether it's on-premise, whether it's on your laptop. You can use Minikube. You can work literally any Kubernetes cluster. What we are trying to do is we're trying to configure Jenkins X so it understands the different kinds of Kubernetes clusters, because there are some things that can be a bit wonky. For example, we need various different things like DNS. We're currently using insecure Docker registries because we run a Docker registry inside Kubernetes, and doing that on-premise is often kind of tricky to talk to it without HTTPS and all those kind of things. So there's a few things we need, but we have run Jenkins X on bare metal servers. That all works fine. All the public clouds, it works fine. It should in theory work on any Kubernetes cluster you can find. We're working with people at Pivotal and Oracle and IBM to work on all of their clusters too. The aim is to work on any Kubernetes cluster. As anyone who's used Kubernetes in anger, it probably knows, it can be challenging to take an application and run on any Kubernetes cluster because there can be differences around things like DNS and load balancers and IPs and whatnot. We are looking to we want to make it as easy as possible for people to use Jenkins X on any cluster. So we are looking to work with something like maybe the Heptio Sonoboy project or something, so we can help verify that the cluster is set up for Jenkins X to avoid people installing Jenkins X and then things kind of breaking or whatever, to help people understand what needs to happen in their cluster before they install it. So if you have an arbitrary cluster that maybe your company manages or creates for you, we kind of want to help make that super simple to just adopt. We have a whole bunch of plugins, by the way, in Jenkins X to customize the install experience for different clouds. So if we found out, for example, PKS the other day uses a slightly different place for the Docker daemon. So we can use GitOps and Helm to configure Jenkins X for different providers. So we're all set up to deal with all these small differences that happen in different kinds of clusters. So please, if you have any issues with your cluster, just raise an issue and we will do our best to make it work as quick as we can. But the quick answer is yes, our aim is to work on every Kubernetes cluster, wherever it is.
Great, thank you, James. We have Jayanth Sai has asked, let me just pull up the question here. How does JX create cluster command have access to cloud infrastructure? So I think that, how does it actually hit a Kubernetes API?
Yes. That's a really good question. So I didn't really explain this at all, but I probably should have. Jenkins X is Kubernetes native, so it uses Kubernetes resources for everything. So let me switch to a screen and show you. For example, in environments, let me use this terminal. If you want to look at the environments in Jenkins X, you can use kubectl get environments, if I can spell it. Well, you can use N for short. And these are the custom resources in Kubernetes. So we're using Kubernetes resources to model everything in Jenkins X. So environments, pipelines, releases, they're all just custom resources in Kubernetes sense. So Jenkins X, the JX command, when I type JX get in, this is using the exact same authentication and certs and everything that kubectl is using. So kubectl is using the file in your home directory. I won't show you mine just in case, but there's a file in the home directory kubeconfig, which is where your configuration for using kubectl lives, right? So if you have any cloud provider or Kubernetes cluster, there's usually a CLI or something to log in to, say, Google or Amazon or Azure. And what that does under the covers is that sets up your kubeconfig. Jenkins X is using that exact same mechanism. So if you can use kubectl to talk to a cluster, Jenkins X will use that to configure your cluster. Now, if you're using JX cluster, say GKE, what that does under the covers is that uses the gcloud command line for Google or AZ for Azure, and soon the EKS one for Amazon. That uses those command line tools to connect to the cloud. So we're using the cloud providers tools to set up the clouds and connect to them. And after that, it's just vanilla Kubernetes REST APIs, right? So it's vanilla Kubernetes stuff. So all of the APIs we use in the JX command line are just Kubernetes REST APIs. So everything's using Kubernetes role-based authentication and all that kind of stuff. So, if you really wanted, you could prevent some people from seeing your environments or pipelines or something. Yes, great question though. Any other questions?
Okay, I will pass another one here. What about saving unit test results as artifacts?
So one thing that's common in the Jenkins ecosystem is to kind of store all sorts of stuff in kind of inside Jenkins, inside the file system of Jenkins. What we kind of recommend people with Jenkins X to do is any kind of artifact, whatever it is, it could be a test report, it could be an artifact, a piece of YAML, a piece of XML, a log file. We kind of want to put those in something like a Nexus and Artifactory, like use a registry for those or repository for those, and put artifacts and things there. If things are more for reporting, like, I don't know, like test results, we're working on a plugin to dump test results, insert test results into something like Elasticsearch so they're easy to query. We have a whole bunch of tooling right now for exporting metadata from Jenkins X into things like Elasticsearch so that you can query, like, how long does it take to get issues fixed, or what's your release frequency, or what's your mean time to recovery, and all those kind of things. So if you want to put output from pipelines somewhere you want to query them, then Elasticsearch would be our recommendation. Otherwise, if it's just literally an artifact like a jar or a POM or whatever, or a node module, put that in Nexus or Artifactory. But yeah, great question.
Okay, another one here, Ihor Antonov asks, does Jenkins X support mono repo workflow? We keep everything in a single Git repo.
Yeah, the quick answer is no. A lot of people use mono repos. We have something called build packs. I didn't really talk too much about them, but build packs are just little packs of files of like reusable Docker files and Jenkins files and Helm charts and stuff. And these build packs have in them the Docker file and the Jenkins file and stuff to do the CI/CD piece. We don't yet have a build pack for a mono repo that can go through a mono repo and determine which things have actually changed and which should you release or not. We did build a tool recently. I was working with Ray from Google, who had a whole bunch of quick starts. And all these quick starts were all about using Spring Boot with Google Cloud, which could be used on any cloud actually, but specifically they can take advantage of Google stuff. And we wanted to add those quick starts into Jenkins X so that anybody could create any of those quick starts. So we actually wrote a little CLI tool that all these quick starts were in a mono repo. And so to make this easy to consume in a CI/CD way, we've got a little tool that literally goes through this mono repo and literally copies the code. Every time you do a pull request on this mono repo, we mirror the code into these individual Git repos. Now, I'm not necessarily saying this is an awesome thing to all do, but if you did use that tool, then the mono repo gets replicated into separate repos. And what that means is we can then just use normal Git commits to know when we should release something. The problem with mono repos is you need some magic tool. So imagine you've got 20 microservices in a mono repo. Every Git commit is going to run a release. And the challenge with mono repos is knowing which pieces you really need to release in that mono repo. So you need to use, I don't know, Bazel or some kind of magic thing that is going to look at the diff in Git and go, which things am I really going to release? If you can put that in the Jenkins file, then you can just use it. But we don't have one of those things yet. Please contribute one if you have some tool that does that. So we kind of prefer there to be separate Git repos. So if you want, you could mirror your mono repo into separate repos so that if you do change one of the microservices, only that one microservice will get a new release and be promoted. So that's our best answer for mono repos right now. Today, we're not awesome at mono repos, but we could certainly improve over time. To be honest, I prefer separate repos for microservices. It feels a bit more microservice-y. It's just easier for people to see when individual microservices really do get changed, right? If you have a mono repo with 20 things and there's loads of commits, it's just easier for humans to see what changes. But we'll certainly help you use mono repos on Jenkins X if you want to join Slack, and we can talk about it, I guess. Good question.
Thanks, James. There's several questions here that are alluding to this similar thing. You feature GitHub. Are there any other integrations, GitLab, Bitbucket, any other source control?
Yes, I should have talked about. Yeah, I should have talked about that. We have a whole range of Git plugins. So the aim is to support every Git provider that anybody could possibly wish to use eventually. Right now, we support GitHub and GitHub Enterprise awesomely. And Bitbucket Cloud is working great, and we have integrations for GitLab, Gitea, and Bitbucket Server, but they're in different stages of maturity. I think probably the next one that will be rock solid is Bitbucket Server. So the two out-of-the-box solutions that work for on-premise Git repositories or private Git repositories will be GitHub Enterprise and Bitbucket Server. We are working on GitLab and Gitea. Gitea is super close. Gitea is like a Go-based open source Git repository server. But I personally am a huge fan of just because it's all written in Go and Go is super cool. And it's kind of tiny. It's like a really tiny Docker container that starts up really fast and it's lean and mean and feels very much like GitHub. I love GitHub though, by the way. GitHub is amazing and I'm super happy that Microsoft bought them. But yes, our aim is to support GitLab and everything people are using. It's just taken us a while to add all the deep integration for all the Git providers because it's not just about cloning the Git repository. What we need is pull requests and the feedback. When a pull request triggers, we need the feedback from the pipeline to go back into the Git repository so that we know that pull requests are green and we can merge and stuff. So it's taken us a little while to get full support for all the Git providers, but it's definitely on our roadmap. We're trying to go as quick as we can to support them all. But yeah, GitHub Enterprise and GitHub is working brilliantly. Bitbucket Cloud is working brilliantly. Bitbucket Server's close, I think. Git is really, really close to having one bug. And then GitLab's, a lot in the pipeline is coming along, and it's not too far away, I don't think.
Fantastic. I think we have time for one more question. It's another aggregated question. A lot of folks are asking about support for multiple clusters across multiple cloud providers. Yes. So how does that work?
That's a brilliant question. I love it. So there's a lot of demand for multiple clusters. This is kind of a common thing in Kubernetes. People kind of say, how many clusters should I have? And there isn't a really good answer of how many clusters you should have. It's kind of one of those things that, for example, you could have a cluster per environment. So one cluster for development, one for testing, one for staging. If you've got 10 teams in your organization, you could have 10 clusters for development, 10 clusters for staging, and 10 for production. Or you might want to group some teams together and share a cluster and whatnot. So there's a lot of different ideas of what's the right number of clusters to have. But absolutely, Jenkins X can work on multiple clusters. The one thing we don't yet do is we don't automatically set up multiple clusters for you. So you literally have to set up a staging cluster or a production cluster, and you kind of have to do that bit by hand. We are working though on a Terraform-based GitOps mechanism to set up and provision all of your Kubernetes clusters on whichever provider you wish, and put Jenkins X on top of it, and then set up your Git providers, teams and organizations and stuff like that. So we hope to have a demo soonish of spinning up, say 3 clusters for dev, staging, production on any provider. And so you could use, I don't know, Amazon for development, Kubernetes, GKE for testing, and maybe EKS for production or whatever. Or you might want 2 production clusters, one on Amazon and one on AWS or whatever. So the quick question is, yes, we absolutely support multiple clusters. We just need to do a bit more work on the tooling to automate setting it up. I mean, the trick is just setting it up. The beauty of GitOps is GitOps isolates the development pipelines from the production and staging environments, right? So one of the issues with CD is sometimes you don't want your development environment to have like cluster admin on production, right? Your security folks would probably be quite scared if your like a Jenkins server had cluster admin on production. So what the lovely thing about multi-cluster with GitOps is, GitOps means the development cluster is just literally submitting pull requests, and the only thing that runs a job to apply those changes runs in the staging environment or the production environment. So you don't have to expose, the production environment to the public with secrets and whatnot. You can keep the job that applies the latest Helm charts in that cluster. So it works beautifully from a security standpoint. So quick answer is yes, we absolutely do support multiple clusters, but we still need some work to do to help automate setting up many clusters. There's a lot of work that the Heptio folks are doing around, they've got a new project that's Gimbal, that's the name, that's trying to help abstract the differences of the multiple clusters, because once you have, say, I don't know, 10 clusters, it can get a bit kind of complicated, switching between them all and all that kind of stuff. So I think in the ecosystem, we'll have more and more tools to help work with many clusters at the same time. So we're hoping to use Heptio's Gimbal to help on that front. But yes, okay. The quick answer is yes.
Yes.
We're hoping to do all of that kind of stuff. Yes.
Okay, that's we're at time. I wanted to thank James for his time. It was incredibly informative for me, and a lot of the feedback and questions in the chat have been incredibly positive. So thank you all for joining. I'm sorry we couldn't get through all the questions. There are 21 open questions still. I encourage you, James has shared different ways in the community that you can provide feedback and ask those questions. But I want to
I'll try, by the way, I'll try blog answers to all of the questions after this. So give me a day or two to catch up, and I'll write a blog with all of the questions we get and answers to them. And just keep the questions coming on Slack in the meantime.
Okay.
Yes.
Fantastic. And the slides and the recording will be online within the next 24 hours. So Caitlin has shared the link in the chat there. So take a look if you missed anything. And thank you all for joining. And we'll see you at a future CNCF webinar. Have a great day.
Thank you. Cheers. Bye-bye.